Welcome to the DIY Honda Garage channel. The error code P1116 indicates a problem with the ECT, Engine Coolant Temperature Sensor 1, circuit in the Honda Civic models from 2006 to 2011. This sensor is critical for monitoring the engine's temperature, providing essential data to the Engine Control Module, ECM, to optimize fuel mixture and ignition timing for efficiency and performance. The ECT Sensor 1 is usually located near the thermostat housing, a vital component of the cooling system that regulates coolant flow. If this sensor fails, it can lead to misreadings of the engine's temperature, causing poor fuel economy and potential overheating issues. In diagnosing this DTC, it is imperative to first note any freeze frame data or snapshots that can provide context to the code and guide troubleshooting efforts. Special attention should be paid if DTC P1111 is also present, as it must be addressed before this one. The ECT Sensor 1 plays a vital role in the vehicle's performance by measuring the temperature of the engine coolant. This measurement is essential for the engine control module to make informed decisions regarding fuel injection and ignition timing. The sensor is typically situated close to the thermostat housing in the engine compartment. The thermostat housing is a critical part of the cooling system that ensures proper coolant flow and engine temperature regulation. By providing accurate temperature readings, ECT Sensor 1 aids in preventing engine overheating and optimizing overall engine performance. Faults with the ECT Sensor 1 can result in performance issues and should be diagnosed promptly to avoid extensive damage to the engine. Therefore, understanding its location and function helps to ensure effective troubleshooting when this DTC is triggered. Several factors can contribute to the activation of the DTC P1116. First and foremost, poor connections and loose terminals at ECT Sensor 1 or ECT Sensor 2 can disrupt signal transmission. These terminals must be inspected thoroughly, as corrosion or a weak connection can lead to erroneous readings. Another potential cause is a faulty ECT sensor itself. If this sensor does not provide accurate resistance readings based on the coolant temperature, it will trigger the DTC. In some cases, the problem might also lie within the Engine Control Module, ECM, which could misinterpret the data received from the ECT sensors. Each of these variables demands careful consideration during the diagnostic process to pinpoint the root cause of the issue accurately. Proper diagnosis involves both visual inspections and electrical testing to identify any degrading components. When DTC P1116 is present, drivers may notice a range of symptoms that indicate potential engine issues. One prominent symptom is engine overheating, which can occur due to the system's inability to regulate temperature properly. This can cause significant harm if not addressed timely. Additionally, poor fuel efficiency may be experienced since incorrect temperature readings can lead to suboptimal fuel-air mixtures. The check engine light will likely illuminate on the dashboard as a warning sign, prompting further investigation. Furthermore, an unstable idle may occur, causing the engine to rev erratically when stationary. Recognizing these symptoms can aid in prompt identification and response to the underlying sensor issue, preventing further damage to the vehicle. The first step in troubleshooting DTC P1116 is to check for poor connections or loose terminals at ECT Sensor 1 and ECT Sensor 2. A loose or corroded connection can result in unreliable sensor readings, which directly affects the performance of the vehicle. It's essential to inspect both sensors' wiring harnesses and connectors thoroughly. If any visible damage, corrosion, or looseness is present, it needs to be rectified immediately. Once any connection issues are addressed, the technician should move on to the next steps in the troubleshooting process. If the connections and terminals are found in good condition, the next step becomes necessary to diagnose the issue more accurately. Ensuring solid electrical connections is critical for accurate sensor function. In the second troubleshooting step, the technician should turn the ignition switch to the on position. This action powers the vehicle's electronic systems without starting the engine. Next, using the HDS Honda Diagnostics system, they will check for any pending or confirmed DTCs. It's essential to identify whether DTC P1116 is stored alongside other codes, particularly DTC P2183. If both codes are present, it indicates a more complex issue involving the coolant temperature monitoring system and requires further investigation into the related components. If only DTC P1116 is indicated, the technician can proceed to the next troubleshooting step. This systematic approach ensures that each suspected problem is evaluated based on the codes present. For the third step, the technician must start the engine and allow it to idle for a duration of 10 minutes. This allows the engine to reach operating temperature, which is crucial for accurate diagnostics. While the engine is idling, the technician should then check ECT sensor 1 in the data list using the HDS. The expected reading for ECT sensor 1 should be around 117 degrees Fahrenheit, 47 degrees Celsius or more. If the reading indicates a temperature of 117 degrees Fahrenheit, 47 degrees Celsius or less, it suggests that ECT sensor 1 is likely at fault and needs to be replaced. The purpose of this check is to ensure that the sensor is providing accurate temperature readings during normal operation. Accurate monitoring is vital for engine performance. In this troubleshooting step, the technician must let the engine continue to idle for an additional 10 minutes. This is significant as it allows the engine systems to stabilize, giving a more accurate reading. After this period, the technician should check ECT sensor 2 in the data list using the HDS. The expected temperature for ECT sensor 2 should be about 140 degrees Fahrenheit, 60 degrees Celsius or less. If the reading is indeed 140 degrees Fahrenheit, 60 degrees Celsius or below, it suggests a problem with ECT sensor 2. The protocol established helps to ensure that both sensors are evaluated properly during the diagnostic process. A failing ECT sensor 2 can also adversely affect engine performance and should not be overlooked. For the fifth troubleshooting step, the ignition switch should be turned to the lock 0 position, which powers down the ignition and electronic systems. This is followed by allowing both ECT sensor 1 and ECT sensor 2 to cool to the ambient temperature. Cooling both components will help ensure their readings can be accurately assessed later in the process. The technician should also take note of the ambient temperature at this stage for comparison purposes. This step is crucial as it helps establish a baseline temperature that will be used to test resistance and functionality of the ECT sensors. A proper comparison against the ambient temperature can help identify any discrepancies in sensor performance. Final verification of repairs is critical after addressing any issues related to DTC P1116. The first part of this step involves ensuring that all identified repairs are completed satisfactorily, which could include replacing faulty sensors or fixing wiring issues. Following this, the technician should recheck for DTCs using the HDS to confirm that the P1116 code and any other related codes have been cleared. Furthermore, it is essential to ensure there are no new DTCs present following repairs. Recording this data is invaluable. Successful completion of this step provides peace of mind that the root cause has been addressed. and the vehicle's performance has been restored to its original state. To prevent the recurrence of issues like DTC P1116 in the future, it's essential to implement a regular preventive maintenance routine. Technicians should regularly inspect ECT sensors to confirm they are functioning correctly and free from damage. In addition, checking all electrical connections related to the sensors should be part of the routine, as corrosion and loose connectors can lead to performance issues. Regular monitoring of coolant levels is also crucial, as low coolant can lead to overheating and misreadings by the sensors. Performing these preventive tasks can significantly reduce the likelihood of DTCs, leading to overall improved engine performance and longevity. Educating the vehicle owner on these maintenance steps can empower them to maintain their vehicle effectively. In summary, addressing DTC P1116 related to the ECT Sensor 1 circuit involves understanding the role of the ECT sensors and how they influence engine performance. The diagnostic process is systematic, beginning with inspecting electrical connections before assessing sensor performance. Timely replacement of faulty sensors is crucial and must be accompanied by thorough verification of repairs made. Preventive maintenance will help mitigate issues in the future, ensuring consistent vehicle performance. Knowledge of these components and their interconnections can significantly enhance troubleshooting effectiveness. As always, keeping detailed records of diagnostics and repairs can be beneficial for future reference. Please like and subscribe to the channel. See you next time.